Welcome to this lesson on nuclear physics for GCSEs. So let's start by describing what is being shown in the diagram. Pause the video now if you need time to consider. From this diagram, we are being shown beta decay. What is happening is a nucleus is emitting a fast-moving electron. This is known as a beta particle. Now it's important to note that that electron did not exist inside the nucleus. It came into existence when a neutron turns into a proton. Today's title is Beta Particles or Beta Decay. Can you name 3 types of ionizing radiation? State what happens to like charges and opposite charges when near each other. State the composition of a beta minus particle. State what is meant by penetration. Compare the relative ionizing potential of all 3 ionizing radiations. And describe the mass and charge of a beta minus particle. If you can't do any of these things, you should go back over the previous lessons: atoms, ionizing radiation, and the dangers of ionizing radiation. So let's take a look at unstable isotopes. There are many ways an isotope can be unstable. It can have too many neutrons, too few neutrons, or be just too large. If an isotope has too many neutrons, one of the neutrons can in fact turn into a proton. When it does this, it emits an electron. We call this a beta minus particle. The reason it needs to emit an electron is for a law called the conservation of charge. If we're creating a positive charge from a neutral, we must also create a negative charge to balance that out. Explain why an isotope may emit a beta minus particle. Figure A shows a light, unstable nucleus with too many neutrons emitting a beta minus particle in order to decrease the number of neutrons, but increase the atomic number, that is to say, the number of protons. This makes it more stable. Sketch a simple version of figure A to show the emission of a beta minus particle from a nucleus. And then label figure A with the number of protons before and after the beta minus decay, and the number of neutrons before and after the beta minus decay. So let's look at the properties of a beta minus particle. Before scientists knew what a beta minus particle was made of, they were able to determine its properties. Placing a beta minus emitter between 2 charged plates, one positive and one negative, beta minus particles would curve away from the negative and towards the positive. Since like charges repel and unlike charges attract, it meant the beta minus particle must be negatively charged. The more curved the path, the larger the charge and the smaller the mass. The path was sharply curved, so it must have a small mass and a high charge. Scientists determined this was the mass and charge of an electron, demonstrating that the beta minus particle was in fact a fast-moving electron being emitted by the nucleus during a radioactive decay. Explain why a beta minus particle will accelerate towards a positive electrode. State what determines the path of a beta minus particle travelling between two charged plates. And consider alpha particles and beta particles will curve in opposite directions in an electric field. Alpha particles and beta particles will also curve in opposite directions in a magnetic field. This is something expected of you to know for your examinations. The fact that alpha and beta curve in opposite directions in either an electric field or a magnetic field. Now let's look at the penetration depth of beta particles. Figures C and D shows that a beta minus particle can penetrate through about 1 meter of air, and it can penetrate thin paper, but cannot penetrate through metal foil. In fact, it's stopped by around 5 millimeters thick sheets of aluminium. This is because beta minus particles are fast moving and small, so they are not likely to collide with atoms in the air or the paper. However, they have a charge of -1, so they can be deflected by electrons and collide with the atoms in denser materials like metals. So denser or thicker materials stop them easily. Sketch a diagram of figures C and D. State the penetration depth of beta minus particles, and explain why beta minus particles do not penetrate far through metals. Now let's look at the uses of beta minus particles. So they're used in quality control systems. So when you're trying to get paper that is all the same thickness throughout, you'll use beta minus particles in order to measure the thickness of that paper. So when paper is manufactured, it's important to keep the thickness constant so as to avoid wasting material. When a beta minus source is placed near paper, most but not all of the beta minus particles will get through. If the paper is thicker, less beta minus particles will make it through. This can be used on a production line to control the thickness of the paper. Since the paper is squashed by rollers, the beta minus source and detector can be linked to the rollers to keep them the right distance apart. Too far apart and the paper is too thick. Too close together and the paper is too thin. The number of beta minus particles getting through can then be used to control that distance between the rollers. If lots get through, if nearly 100% get through, that means the paper is too thin. Whereas if very few beta minus particles made it through, the paper would be extremely thick. Explain how a beta minus source and detector can indicate the thickness of paper. Explain what happens if the paper is too thick, using the keywords beta minus particles and detector. Finally, let's do some problem-solving activities. State what happens to the atomic number and mass number of a nucleus when it emits a beta minus particle. Use a periodic table to identify what element will be produced when the following nuclei emit a beta minus particle: hydrogen 3, lithium 8, gallium 71, and krypton 85. For the isotopes in question 2, state their mass number and atomic number after the beta minus decay. If you want to read the textbook page, pause the video now. The questions at the bottom right are the same questions you've done. There are also a couple of revision activities for you.